Today we shall read circle part 2 and in my previous class I have already explained some theorems, and today we shall discuss these 4 theorems, and among them the first one is the angle which an arc of a circle subtends at the center is double that which it subtends at any point on the remaining part of the circumference. So before that, I want to tell you, just to see this picture and this theorem that you can able to understand. This is the center, and this is the angle, and another angle is this one. Let A, B, C, and this point is D, and the center is O. So the theorem has says the angle which an arc. First of all, you see this AB is an arc. It is part of a circumference. And the angle that arc subtended at the center, this is the center. So your AOB is the angle which has been subtended by the arc AB, and it is double than which it subtends at any point of the remaining part of the circumference. So except your AB, the ACB part is the remaining part of the circumference. So in remaining part of the circumference, that is in ACB part of the greater arc, wherever an angle is formed, then that will be half of the center angle, or in other words, the center angle is twice of that circumference angle. Here in this case you can see that our center angle is your center angle is AOB, while the angle subtended at the other part of the circumference, so that is ACB, that is at the angle at the remaining part. Remaining part of the circumference. Now you see, we have been asked to prove that angle AOB is equal to twice of angle ACB, or in other way, your half of angle AOB is equal to angle ACB. The same thing. Now you see, how can we prove this one? You can see we have construct join OC, and that has been produced up to D. So your AOD angle, that you can see, this angle, it is the exterior angle of triangle AOC. AOD is the exterior angle of triangle AOC, and that is equal to your ACO angle plus CAO angle. That we have already read, that exterior angle angle is twice of the interior opposite angle. Sorry, it is AOC. Sorry, and twice of the interior angle, it is AOD, that you can see. And that is why it is ACO plus CO. In a similar way, we can prove in triangle and if B angle BOD is equal to OCB plus CBO. And that is BOD is an exterior angle of triangle BOC, hence BOD is equal to this one. And as you know that both these case AOC equals to CAO because AO and OC are the two radius. So this equal to this one, and also we can write ACO equals to CAO because of radius equal radius. This one means ACO equals to your CAO because your OC and AO are the two radius. In a similar way, we can write your OCB equals to CBO. OCB equals to CBO because your this is OC and OB are the radius. Now we can say that your AOD angle plus BOD angle is equal to your 2ACO angle plus 2BCO angle. You may ask me, sir, how? Because I have replaced the CO with OCA because they are equal. So finally we can see that your AOB angle is equal to, if we take 2 common, your ACO angle plus BCO angle. So, and that you can see which equals to ACB angle. Now we have been asked that your center angle is AOB, and finally we have proved that AOB equals to 2ACB. And in any type, suppose if you draw an angle like this, in a similar way also you can prove it. Now come for the second theorem. In the second theorem, it is given that your angles in the same segment are equal. Just I am telling you the same thing that I have already told in the third theorem. Same segment are equal, and we have drawn this one. Now it becomes a segment. Means your this is segment. In this picture, your AB is a segment, ACB is a segment. AB is your minor segment and the ACB is your major segment. And here we have been asked to prove, let you may name it F, to be proved your ACB angle equals to AFB angle, angles in the same segment. So both these angles, your angle ACB and angle AFB, are in the major segment, that is ACB segment. And here you see how can you prove them equal. So we have seen that center angle is always twice of the angles of the remaining part of the circumference. As here in this case, your AOB is the center angle, hence AOB equals to 2ACB, that we have already proved. Similarly, your angle AOB equals to 2AFB. You can see both AOB is the fixed center angle, and here it is AFB is also a remaining part of the circumference, and your ACB also remaining part of the circumference, and that is why your AOB is equal to 2ACB and AOB is also equals to 2AFB. Hence you can see whenever this is your left side becomes equal, you can write 2ACB angle equals to 2AFB angle. So your ACB angle equals to AFB angle. Students, you have to remember all these things because while you are doing sums, and these things will be used very practically, and there you have to write the region. Suppose these things have been given, so why they are equal, you have to write yes, they are on the same segment. Then come for the third theorem. The angle in the semicircle is a right angle. So here you see, we shall go for the other picture. Now you see it is this one, and it is the center, your O, and this one is an angle, means your AB, and this is C. So here we have to prove that your ACB angle becomes 90 degree, or right angle, whatever you mean. First you see, as the theorem says, semicircle. Your ACB is the semicircle because O is the center and the AB is the diameter. The diameter has divided the circle into two semicircles, and your ACB is the semicircle angle. And the same theorem, just to remember, that angle, an arc which subtended an angle at the center, that angle is twice of the angle at the remaining part of the circumference. Here, your AB arc has subtended the angle this one. Your AOB angle equals to 180, and that is your center angle in this case. Okay. Now, as you have read, center angle is twice of the angle at the remaining part of circumference. Hence, your angle AOB equals to 2ACB. Angle 2ACB. Hence, only A, and that is equal to 180 degree. Appear your 2ACB equals to 180 degree. Atep only ACB equals to 180 degree by 2, that is 90 degree. And here we have to that angle at the semicircle is an right angle, or you may say it 90 degrees. And come for the fourth theorem, as here it is mentioned, that the angles in a cyclic quadrilateral, first of all I want to tell cyclic quadrilateral, the quadrilateral has been inscribed inside the circle, and here you see this one, and the quadrilateral, it is like this, and here is the your center, this one, this, and you have to prove, and we have been asked to prove that this is your center, A, B, C, D, and it is, we have been asked to prove opposite angles. So to be proved, your ABC angle plus ABC angle equals to 180 degree. As you see that your angle AOC is the center angle, and AOC angle equals to twice of ADC angle, because your ADC angle is at the remaining part of the circumference and it is on the arc ABC. In a similar way, AOC reflects. In a similar way, your AOC reflects is equal to 2ABC, because that is also center angle and this angle is also your angle at the remaining part of the circumference. So this equals to this one. And if we add them, your AOC plus AOC reflex, which equals to 360, because that is a total full circle. So that is 260, which equals to 2ADC plus 2ABC. Now you see, if you take 2 common, 2ADC plus 2ABC, if you take 2 common, angle ADC plus angle ABC equals to 360. Otherwise, only ADC angle plus ABC angle equals to 180. And in a similar way, also we can prove your BAD angle and your BCD angle also 180. So while you are doing sums, while there is a sum, they are relating to these theorems and also the theorems which I have already discussed, you have to remember of all the rules and you have to minutely read the sum, and thereafter you apply the theorems, and the theorems will be, and your sum, you will feel it easy to solve it. But you have to remember these things. More will be discussed in my next class.